All right. I think we've never seen this situation before where a single vector is first broken up into vertical and horizontal components, ty and tx, and then secondly broken up into components again from a different perspective, from a different coordinate system. Here the perspective is from this beam where we're interested in vertical and perpendicular or vertical component relative to the beam and horizontal or parallel component relative to the beam. Well, we have to be careful with geometry. What's this angle here? Well, if this is perpendicular to the beam, then this is a right angle in there. And altogether, this is 90 degrees. I've already been told this is 40 degrees, so this must be 50 degrees in there. So the torque caused by this tension is equal to, again, perpendicular force times the length. The length is, this is really complicated because the length is the complete L minus, there's this little, I don't even know what it is in your picture, but there's this little overhang part. So the lever arm is equal to the full length of the beam minus this little part of the length. I call it L prime. So that's the length of the lever arm. The full length L of the beam minus this part. That's the lever arm. The perpendicular force is the perpendicular part of the tension, and that is equal to the tension. This is the adjacent side to 50 degrees, not the opposite side, it's the adjacent side. So it's cos 50 degrees times the tension. Cos 50 degrees times the tension. And this is in the counterclockwise direction, so this is positive, and I don't think I addressed the weight actually causes a counterclockwise torque, so this is actually negative there. And there are no other forces. There's only the tension and the weight. These forces down there have a lever arm of L equals 0, so they don't contribute to the tension. To the torque. Those both add up to 0, so they have equal magnitudes. The weight is mg, so I'm going to put mg in there. Cos 30 degrees, L over 2 is equal to cos 50 degrees, tension, and the length of that length there. Now, I think we know most things in this equation, don't we? We know G, we know M, we know cos 30, we know L2, we know cos 50. We don't know the tension, we know these two lengths. So from this torque equation, we can find the tension. So you guys can find the tension from this torque equation. You can solve for the tension. So now we know the tension, that's part A. It was a difficult part. Part B, how hard does the beam push into the wall? Well, how hard does the beam push into the wall? That's the same, it's equal and opposite to how hard the wall pushes against the beam. Those are both, so how hard the beam, yes. So if we know f of x and f of y, then how hard does the beam push in the wall is equal and opposite to how hard these push on the beam. So let's figure out fx and fy. Since we know tension now, we can find tension of x. So let's go right up here to the top. Tx is equal to f of x. Tx is equal to tension. X is the adjacent side to that 10 degrees, so that's cos 10 degrees. is equal to f of x. So now we know f of x. F of y can similarly be found by this second equation here. We know the weight. We know that's equal to ty. Ty is the opposite side of the angle 10 degrees. So that would be sine of 10 degrees times the tension in the wire plus this unknown f of y. We can solve for f of y now. There. And how hard, what's the magnitude? So those are the two components. If we really want to know what that force is, we can use Pythagoras. Because there's some kind of net. There's a f of y, f of x. They cause an f to push out, and this is pushing opposite. So from two components, you can always find the vector itself, f from. So there's the function. There's the force f. It's going to be related triangularly to its two components, f of x, f of y. I just didn't write it there. Okay, so you can solve part B. So this is difficult. This is especially interesting because the single vector t we figured out components x and y, and we also, from the perspective of just a vertical horizontal coordinate system, and we also figured out the perpendicular and parallel components and used them in two different equations. That's the interesting part about this question.